Okay, now we will talk about fallacies. Several common fallacies arise in incorrect arguments. And going back to the topic before, the rule of inference. Argument is a sequence of statements that ends with a conclusion. And a valid argument means that the conclusion or final statement of the argument must follow from the truth of the preceding statements or premises of the argument. This means that a valid argument arrives at a conclusion which is always true. And with that, we use the rule of inference because rule of inference is used as template for constructing the valid arguments. But what about the invalid arguments? Well, invalid arguments arrives at a conclusion which is not always true. So, fallacies is used on this part because fallacies resembles rules of inference but are based on contingencies rather than tautologies. These are discussed to show the distinction between the valid and the invalid arguments or the correct and incorrect reasoning. There are two types of fallacies. The first fallacy is a fallacy of affirming the conclusion, which states that P implies Q and Q, therefore P. Sometimes this proposition is being misinterpreted as true, but this statement is false or not a tautology. For example, you're going to solve this one as propositional equivalence. And Q implies P. Okay, if we're going to solve this one, this will become not P or Q, and Q or P. And this will become P and not Q, or not Q. And put some bracket, or P. Okay, so this will become not Q or P. So it will end up like that. And if we're going to use the truth table for this example, when P is false, example P is false, so it will become F, then Q is true, implies T. Okay, so example P is false and then Q is true. So F implies T, this is true. This is true. F implies T. This will become T and T. So this will become true implies P, which is false. The answer will be false. So again, in whatever kind of process or method, it will end up to false. Okay, let's proceed to an example. Is the following argument valid? If you do every problem in this book, then you will learn discrete mathematics. You'll learn discrete mathematics, therefore, you did every problem on this book. Now let's assign variable to the preposition. Let P be you did every problem in this book. And let Q be the preposition you learned discrete mathematics. So, the form of this argument will be, that is, if you do every problem in this book, that is P, then you will learn mathematics, implies Q. You learned discrete math and Q, which is you learn discrete math, then P. Okay, so the form of this statement will be something like this. If P implies Q and Q, then P. So it looks like the fallacy of affirming conclusion. Now this statement is false because this argument is an incorrect argument. So using the fallacy of affirming the conclusion. And indeed, it is possible for you to learn discrete mathematics in some other way than by doing every problem in this book. And of course, you may learn discrete mathematics by reading, listening to lectures, doing some, but not all the problems in this book, and so on. So that is the fallacy of affirming the conclusion. The second kind of fallacy is the fallacy of denying the hypothesis. It states that P implies Q and not P, therefore not Q. This is also not a tautology. Of course, if you're going to solve this one using propositional equivalence, it is P implies Q and not P, therefore not Q, which is implies not Q. So this will become not P or Q and not P or not Q. Okay, so it will become P and not Q or P or not Q. And based from the rule of absorption, it will become P or not Q. And of course, this is not a tautology. So it will end up here. Now if we're going to solve this one using the truth table, so P implies Q, this will become P is false, so F implies to Q, which is true. So F implies T, it is T. So T and not P, which is T and not P, which is truth, this is also true. So true implies false. So this is true implies false because Q there is false, because Q is true and not Q is false. So T implies F, this is false. So in any method, of course, again, it will output false. Okay, so that is the explanation behind the fallacy of denying the hypothesis. Now let's proceed to an example. Okay, so following from the same example, let P be you did every problem in this book, and let Q be the proposition you learned discrete mathematics. So it is not a tautology because it is false when P is false and Q is true. And many incorrect arguments use this incorrectly as a rule of inference. Thus, this type of incorrect reasoning is, it's called as the fallacy of denying the hypothesis. So, it is possible. So, on this statement, it will become, you did every problem in this book, then you learn discrete mathematics. And you did not do every problem in this book, then you did not learn discrete mathematics. Now, it is possible that you learn discrete mathematics, of course, even if you did not do every problem in this book. And this incorrect argument is of the form P implies Q and not P imply not Q, which is the fallacy of denying the hypothesis.